Across the world, there are ancient stone structures so precise that even modern engineers struggle to explain how they were made. These are not myths, not legends passed down through folklore, but physical objects that still exist. Massive blocks of stone, weighing dozens or even hundreds of tons, cut and fitted together with a level of accuracy that seems profoundly out of place in the distant past. At first glance, they appear solid, silent, inert, just stone. But when measured, examined, and compared against what we know of ancient tools, something feels immediately wrong. The surfaces are too flat, the joints are too tight, the angles are too exact. In many cases, not even a blade can slide between stones that were supposedly shaped thousands of years ago using primitive implements. This is where the discomfort begins. Because if these structures were truly made with simple stone hammers, wooden levers, and copper chisels, as the standard historical narrative insists, then the results should reflect those limitations. We should expect uneven surfaces, visible tool marks, crude approximations. That is what we see in many genuinely primitive constructions. But here, again and again, we find the opposite: precision that rivals and sometimes exceeds modern stone masonry. If this story is resonating with you, leave a comment telling us where you're watching from and what time it is there. The question is not whether these stones exist. They do. The question is why they look the way they do, and why their precision is so rarely discussed outside specialized circles. One of the first things engineers notice when studying these megaliths is the consistency. Random effort does not produce consistent results. Precision repeated across hundreds of blocks suggests process, planning, and control. It implies not just strength, but knowledge. Knowledge of geometry, measurement, and material behavior. Consider what it takes to produce a perfectly flat stone surface. Even today, achieving true flatness requires calibrated tools, controlled pressure, and often abrasive processes refined over time. Stone does not naturally break into smooth planes. It fractures unpredictably. To tame it, to shape it deliberately, requires more than force. It requires technique. Yet in many ancient sites, we find stone faces that are not only flat, but aligned across multiple axes, horizontal surfaces that are level over several meters, vertical faces that meet at near-perfect right angles. In some cases, interior corners so sharp and precise they appear machined rather than carved. And these features are not isolated anomalies. They appear repeatedly across different regions, cultures, and time periods, often in places where the official explanation relies on assumptions rather than demonstrated methods. This is where the narrative begins to strain. When archaeologists encounter a stone structure that clearly exceeds the expected technological capacity of its attributed builders, the explanation is often framed in careful language. Phrases like remarkable craftsmanship, highly skilled labor, or exceptional cultural achievement are used. These descriptions sound impressive, but they avoid the central issue. Skill alone does not replace missing tools. Craftsmanship cannot bypass physical constraints. An engineer approaching the same structure asks a different set of questions. What tools would be required to make this cut? How much force is needed? What tolerances are involved? How long would it take? And most importantly, where is the evidence of the process? In many cases, that evidence is conspicuously absent. There are no discarded tool heads capable of producing such results. No intermediate stage blocks showing gradual refinement. No experimental reconstructions that convincingly replicate the precision using the proposed methods. Instead, we are asked to accept that it was done somehow, because it must have been. This acceptance is often taught early. In school textbooks, ancient builders are portrayed as ingenious within their limits, overcoming challenges with clever improvisation. That image is comforting. It preserves a neat timeline of progress, primitive to advanced, simple to complex. But the stones themselves do not always follow that script. What makes this even more unsettling is that many of these megalithic structures predate known iron tools. Some are attributed to periods when copper was the hardest workable metal available. Copper, however, is significantly softer than many of the stones being cut. It deforms easily. It blunts quickly. Against hard granite or basalt, copper tools are not just inefficient, they are largely ineffective. To compensate, theories often invoke sand as an abrasive or extended time frames involving massive labor forces. But even these explanations struggle when faced with the scale and uniformity of the work. Precision at this level, repeated across massive blocks, would require not just time, but control. Control that implies specialized devices or lost techniques. And here is where the unease deepens. Because once you accept that these stones show signs of advanced planning and execution, you are forced to confront an uncomfortable possibility. Either our understanding of ancient capabilities is incomplete, or the timeline itself is flawed. Perhaps both. This does not require invoking fantastical explanations, no speculation about non-human builders, no appeal to science fiction. Only a sober acknowledgement that the physical evidence does not neatly align with the story we tell about our past. In engineering, results matter more than assumptions. If a structure performs beyond the limits of the tools we believe were available, the correct response is not to stretch the assumptions, it is to re-examine them. Yet re-examination is precisely what seems to be missing. These stones are often admired, photographed and labeled, but rarely interrogated. Their precision is treated as a curiosity, not a problem. And problems are dangerous because problems demand answers. As we move forward, we will look more closely at specific features that make these megaliths so difficult to explain. The impossibly straight lines, the seamless joints, the surfaces that behave more like machined components than hand-carved rock. Each of these details adds weight to the same quiet question. What if these stones are not just remnants of ancient effort, but evidence of ancient knowledge we no longer fully understand? At the heart of many ancient megalithic sites lies a feature that quietly defies explanation: the presence of impossibly straight lines, etched, carved, or embedded into solid stone, often extending several meters without deviation. These lines are not artistic embellishments. They are functional cuts, guide marks, or joins that demonstrate a mastery of material and geometry far beyond what conventional history attributes to their makers. Let us begin with a specific case: the stone blocks of Ollantaytambo, Peru. Here, massive andesite stones, each weighing up to 70 tons, were transported across a valley and precisely aligned atop a mountain terrace. The joins between them are tight, but more astonishing is the consistency of the cuts. Deep grooves, often rectangular in cross-section, are carved into the rock with a symmetry and depth that suggest the use of calibrated cutting tools. Even under close inspection, these grooves maintain a uniform width and depth. There are no signs of gradual wear or imprecision. Engineers examining these features have noted that reproducing similar grooves with hand tools and sand would result in uneven, erratic marks, not the clean channels we see here. The same phenomenon appears in Egypt, particularly in the temples of Abydos and the Osirian. Gigantic blocks of red granite, some weighing up to 100 tons, are shaped with interior corners so precise they suggest the use of hardened metal saws or advanced abrasives, neither of which are part of the standard archaeological toolkit for that era. One particularly telling feature is the presence of parallel lines, rows of shallow, evenly spaced striations that run across flat surfaces. These are not ornamental. In modern stone cutting, such lines are typically the result of circular saw blades or rotary grinders. The width, depth, and spacing of these lines often correspond closely to the marks left by high-speed tools. But the problem is clear: these sites predate the existence of any known high-speed rotary equipment. We are left with two choices. Either these marks are misunderstood and produced by unknown manual techniques, or they are evidence of a lost technology capable of precision stone manipulation. Another site, Sacsayhuamán, high in the Andes, features immense polygonal walls made from limestone and andesite. These stones interlock with such accuracy that not even a needle can pass between them. But more remarkable than the fit is the surface itself. In many cases, the stones are subtly concave or convex, matching the adjacent piece with sculptural perfection. To achieve this, one would need to constantly test the stones against one another during shaping, correcting for the slightest inconsistencies, a process that even today would require templates, measurement instruments, and tooling jigs. The absence of chisel marks or rough tool signatures on these surfaces adds to the enigma. A rough-hewn stone refined by hand should carry scars of the process. Instead, we find surfaces that are eerily smooth, sometimes polished, without a trace of the supposed primitive technique. Some archaeologists suggest these surfaces were pounded into shape using stone hammers over long periods. This theory presumes that repeated blunt impacts can create symmetrical curves and flawless mating surfaces, an idea that strains credulity. To argue that randomness produces precision is to invert the very logic of engineering. Engineers know that consistency is not a byproduct of brute force. It is the result of control. Precision, by definition, requires feedback, the ability to measure, adjust, and correct in real time. Without tools to do this, the shaping of interlocking surfaces becomes an act of blind luck, and luck does not scale. Yet these structures span entire walls, courtyards, even cities. In Baalbek, Lebanon, the Temple of Jupiter contains the so-called trilithon stones, each weighing upwards of 800 tons. These stones are not just large, they are precisely placed atop smaller base blocks, leveled and aligned. The logistical challenge of moving them is one issue, but the precision with which they sit, flush against adjacent stones, aligned over distances of 20 to 30 meters, poses a deeper question. How? No wooden sled or ramp system explains this alignment. The moment you accept the reality of such precision, you are forced to entertain alternatives, none of which are currently acknowledged in mainstream archaeological discourse. The answer, or at least the process of seeking one, lies not in mythology, but in method. When modern engineers examine these lines, joints, and cuts, they recognize signatures, not of artistry, but of procedure. Many of these features resemble outputs from known tools, diamond wire saws, core drills, high-speed grinders. But these tools require electricity, metallurgy, and infrastructure. If these stones truly predate such technologies, then we are left with two equally uncomfortable implications. Either these technologies existed and were lost, or our dating methods and historical assumptions are flawed. Neither option sits easily within the traditional framework of history. What further complicates the picture is the repetition of these anomalies across cultures and continents. In Japan, the Ishibutai Kofun tomb contains massive granite slabs fitted with similar precision. In India, the Vitala temple in Hampi shows columns and carvings that hint at rotary tool use. Across Central America, in places like Copan and Tikal, we find stone surfaces with nearly identical machining-like qualities. If these civilizations developed independently, as the academic consensus holds, then why do we see such consistent signatures of precision across them? Was this knowledge shared? Was it rediscovered multiple times? Or is there a deeper, earlier origin point that ties them together? A forgotten chapter of human history, now buried beneath assumption and time? As we continue, we will examine the voices of modern engineers themselves, the professionals who have stood before these stones and admitted, without hesitation, that something doesn't add up. Their testimony adds weight to the suspicion already forming in the minds of millions, that we have not been told the full story. When faced with the stones, the engineers fall silent, not because they have no words, but because they recognize something most of us don't. These marks, these joints, these impossibly flat faces, aren't relics of crude experimentation. They are the outcomes of a refined process. And process in engineering means method, iteration, tools, and control. Over the past several decades, a quiet group of professionals, civil engineers, materials scientists, and architects, have begun to examine these ancient megalithic structures not as archaeologists but as technicians. What they find often shocks them, not because the materials are unfamiliar, but because the techniques required to manipulate them appear far too advanced for the time periods assigned to them. One such voice is Christopher Dunn, a manufacturing engineer with decades of experience in high-precision machining. After personally visiting sites like the Great Pyramid of Giza and the temples of Karnak and Abydos, Dunn concluded that many of the stone features resemble the output of high-precision industrial tools, such as diamond-tipped saws, ultrasonic drills, and computer-controlled lathes. In particular, he studied the infamous sarcophagus inside the king's chamber of the Great Pyramid. Carved from a single block of hard granite, its inner surfaces are polished to near optical flatness. Measuring tools indicate that the interior walls are parallel to within thousandths of an inch. This isn't hand-chiseled work. It's machining, at a level most ancient cultures shouldn't have approached. Another troubling feature noted by Dunn and others is tool symmetry. When a modern rotary saw cuts stone, it leaves behind subtle circular striations, evidence of the blade's rotation. These signatures are identifiable, predictable, and measurable. At multiple sites across Egypt, Peru, and India, similar circular patterns appear, sometimes with matching radius curves that suggest consistent, repeatable motion. These aren't the chaotic scars of pounding stones or chiseling. They're patterns. Many engineers, upon seeing these sites in person, report an uncomfortable realization. These cuts are too clean, the transitions too sharp, the angles too precise. You don't get that from guesswork or brute force. You get that from tooling, from calibration, from process control, something that should only exist in modern industrial environments. Yet when they raise these concerns in academic circles, the response is often not curiosity, but silence. Why? Because the implications ripple outward. If a stone block, dated to 2000 BCE, shows signs of lathe work, then either the dating is wrong, or the timeline of technology development is incomplete. Either answer disrupts centuries of academic consensus. It introduces chaos into an orderly view of human advancement, from primitive to complex, from tribal to technological. And academia does not like chaos. But engineers have no such loyalty to historical narratives. Their only loyalty is to the material, the process, the result. They see in these stones the language of their trade, and they know what it means when that language appears in places it shouldn't. Some engineers have tried to recreate the features using known ancient tools, copper chisels, pounding stones, and sand-based abrasives. The results are universally underwhelming. Cuts are uneven, surfaces rough, time frames enormous. Even with extensive labor forces and perfect coordination, the required precision is simply not feasible with those tools. This leads to another important distinction: possible versus practical. Could primitive tools theoretically produce a flat surface over months or years of work? Maybe. But could those same tools produce hundreds of such surfaces across thousands of blocks, all within aligned structures? Not without a system, not without a repeatable method, not without a technology base. This is where many professionals begin to drift toward quiet heresy, not claiming alien involvement, but suggesting the existence of a lost phase of human engineering, a civilization or culture with advanced knowledge, now erased or buried by time, whose artifacts are still visible in the form of impossible stones. The pushback, of course, is immediate. Where are the tools? Academics ask. Where are the machines? But this question ignores the fragility of infrastructure. Tools rust, machines corrode, buildings collapse. Only the hardest materials, stone, survive the millennia. And ironically, it is in these stones that we see the clearest signatures of something greater. It is also worth noting the selective blindness of official narratives. When a modern engineer publishes findings on the technical anomalies of ancient sites, the response is rarely a detailed rebuttal. Instead, it's a kind of quiet dismissal, a refusal to engage. This silence is not the product of evidence, but of discomfort, because once you open the door to doubt, it cannot be closed easily. And yet, more voices are speaking. Engineers, architects, and technicians who are not theorists, not authors, not conspiracy-minded YouTubers, but professionals who have dedicated their lives to precision, materials, and process control. They don't claim to know who built these structures, but they know what it takes to make them, and they know we're not being told the whole story. A Japanese stonemason, after studying the fit of blocks at Sacsayhuamán, simply said, "This is not done with hammer and chisel, not even close." A German mechanical engineer, visiting the Osirian in Egypt, remarked, "We'd need diamond saws to make these today." Their statements aren't ideological, they're observational. They come from experience, from touch, from measurement, and together they form a chorus, a slow, growing acknowledgement that something doesn't add up. As we continue, we must ask, if the tools don't match the results, what does? Could there be a different explanation, one that accounts for the materials, the precision, and the silence? Or are we simply afraid to look? The mainstream explanation for these ancient wonders hinges on a simple narrative: determination and primitive tools. That ancient builders with copper chisels, pounding stones, and endless patience managed to shape, transport, and position multi-ton megaliths with astonishing precision. That with enough time and manpower, anything was possible. But this explanation begins to unravel when confronted with the physical reality of the stones themselves. Let's consider granite. a material featured prominently in many megalithic sites around the world. It ranks between 6 and 7 on the Mohs hardness scale. Copper, by contrast, ranks around 3. That's not a small difference, it's the difference between a spoon and a drill bit. In practical terms, copper tools are incapable of cutting granite in a controlled, precise way. They deform under pressure. They wear down quickly. They shatter or flatten. And yet granite was cut, carved, and shaped in antiquity, not crudely, but with detail, with geometry, with purpose. To bridge this gap, some have suggested that ancient builders used copper tools combined with abrasives like quartz sand. While this method can technically abrade hard surfaces over time, it lacks precision. The cuts are slow, irregular, and extremely difficult to control. They might explain rough hollows or smoothing, but not the clean, sharp lines, straight boreholes, or matching surfaces that we observe in many megalithic structures. In Egypt's Aswan quarry, there's a half-finished obelisk weighing over 200 tons. Its base shows signs of channel cutting deep into the granite bedrock. If this work was done with stone balls or copper chisels, the process would have required generations of consistent, careful labor. Yet there's no evidence of such extended occupation or the accumulation of discarded tools and debris one would expect from such an effort. Now shift your attention to Peru, where massive andesite blocks were supposedly shaped with bronze or stone tools. Andesite is nearly as hard as granite. The standard story requires us to believe that thousands of man-hours were spent carefully pounding, chiseling, and fitting these stones into complex interlocking patterns with no mortar and no measurable gaps. The problem is not effort, it's accuracy, because primitive tools do not lend themselves to control. Without precision instruments, feedback mechanisms, and templating systems, you cannot reliably achieve consistent results. And yet we see not just one precise stone, but entire walls. Not just one culture, but many, separated by oceans and centuries, achieving results that look strikingly similar. There's another critical dimension to consider: scalability. If a technique truly works, if it can produce precision at scale, we should expect to find evidence of its development. Intermediate steps, practice runs, trial and error phases, but these are curiously absent. Instead, we find what appears to be sudden, mature application. The first appearance of these techniques in many sites is already at full scale and full precision. This violates what engineers and historians alike recognize as a standard curve of innovation. No technology appears fully formed. It evolves. It leaves behind a trail. But here, that trail is missing, or erased. And then there's the cultural inconsistency. Many of the cultures attributed with creating these sites left behind artwork, pottery, tools, and records. But these often do not match the sophistication of the megaliths themselves. The dissonance is striking. Imagine finding a Boeing 747 next to a medieval village. That's the level of mismatch we're dealing with. The leap from carving wood or bone to producing seamless, multi-ton stone assemblies is not evolutionary. It's disruptive, abrupt. Some researchers suggest that the explanation lies not in the tools, but in the mindset, that perhaps ancient builders had a more intuitive or spiritual connection with materials. While this view honors the mystery, it avoids the mechanical reality, because regardless of intention or intuition, shaping hard stone requires force, abrasion, guidance, and precision. And so we arrive at the real crossroads. Were the tools primitive, or is our story of history incomplete? Could it be that we are looking at the aftermath of a lost technological phase in human civilization, one that achieved high levels of engineering, then disappeared through catastrophe, war, or time? This isn't speculation for its own sake. It's a hypothesis grounded in observable anomalies. Holes drilled into granite with apparent spiral striations, channels cut into basalt with smooth, uniform sides, surfaces flat across meters with no visible error. These are not isolated cases. They recur, across continents, across time frames, from Egypt to Bolivia, from Turkey to India, from the Göbekli Tepe circles to the trilithons of Baalbek. The same signatures appear again and again: precision, consistency, and control, without the supporting evidence of how they were achieved. And yet, the academic response remains unchanged: primitive tools, lots of time, and incredible patience. This explanation survives not because it fits the evidence, but because it fits the model. It preserves the progression we've been taught. But models are only as good as the data they accommodate. And right now, the data is pointing in another direction. There is no shame in admitting that we don't know, that we may have lost something. That history, like geology, is layered, and not all layers survive intact. But the cost of clinging to a flawed story is higher than we think. It's not just about misrepresenting the past. It's about cutting ourselves off from a deeper truth about human potential, what we once were and what we might become again. In the next section, we'll explore the deeper implications of geometry, not just as a tool of design, but as a language, encoded in stone, waiting to be read. Geometry is not an accident of form. It is the fingerprint of intention. When we look closely at the world's ancient megalithic structures, a recurring theme emerges: the use of precise, often complex geometrical patterns. These aren't merely aesthetic decisions, they are functional, mathematical, and deliberate. And their presence raises a deeper, more disturbing question. How did these so-called primitive cultures come to understand and apply such advanced geometry, often with greater precision than we can easily replicate today? Consider the polygonal masonry of Sacsayhuamán. The stones are not simply stacked. They are interlocked through intricate, multi-angled cuts. Each stone fits into its neighbors like a piece of a three-dimensional puzzle. The shapes follow no repeating pattern. And yet the layout is stable, earthquake-resistant, and executed with uncanny precision. This design is not just functional. It requires a deep understanding of how forces travel through complex junctions. To create such interlocking forms, one must have knowledge of angles, fit, and structural load. It's not enough to eyeball the shapes. These joints show evidence of planning, of templates, of correction. And because they follow no standard shape, each one is unique, custom crafted to align with its adjacent stones. The layout itself becomes a coded language of precision, embedded into the very walls of ancient cities. In Egypt, the floor of the Valley Temple near the Sphinx is constructed from megalithic limestone blocks, some weighing more than 100 tons, cut and placed with astonishing accuracy. But more than that, the blocks align along diagonals, not just square grids. That kind of alignment suggests an understanding of angular geometry and site orientation, especially when these alignments match celestial references. It continues at places like Puma Punku, where andesite H-blocks display internal angles that are not only consistent, but match across blocks that seem mass-produced. The tolerance levels measured at these sites are often within fractions of a millimeter. In the absence of modern surveying instruments, lathes, and micrometers, how was this done? These structures don't just demonstrate geometry, they demand it. In fact, several researchers have gone further, proposing that sacred geometry, ratios like phi, 1.618, pi, 3.11415, and other irrational constants, appear embedded within the layout of these ancient sites. While some may interpret these patterns as coincidence or retrofitted analysis, the consistency across continents suggests something more deliberate. In the construction of Stonehenge, for example, multiple alignments are astronomically precise. Solstices, equinoxes, and lunar standstills are encoded in the positioning of the stones. These aren't accidental alignments. They reflect observational astronomy over centuries, combined with geometric expression. And yet, the builders supposedly had no writing, no mathematics, no precision instruments. If geometry was understood, it must have been passed down, practiced, taught. But where are the schools? The manuscripts? The artifacts of education? We find none. Only the output remains, etched in stone, mute but unyielding. This silence leads some to speculate that the knowledge was not transmitted the way we expect, in texts or diagrams, but embodied in oral traditions, ritual practice, or embedded in the construction process itself. That perhaps the builders didn't learn geometry in the modern sense, but inherited methods so refined they no longer needed explanation. That possibility introduces a sobering thought. What if knowledge, once truly internalized, leaves no trace except its outcome? Still, the mathematical precision of these structures implies more than intuition. It requires measurement. It requires comparison. It requires tools, physical or conceptual. The problem is, such tools are missing from the archaeological record. We do not find protractors, compasses, angle gauges, or surveying rods that would account for these feats. No ancient lathes, no core drills, no saw guides, and yet the outcomes suggest their use, or their analogs. This raises a possibility that is often ignored in traditional historical frameworks, that the tools used by these builders may not have resembled our own, that their methods, while achieving the same results, may have followed different principles, perhaps methods using sound, light, pressure, or resonance. We do not need to embrace pseudoscience to acknowledge this. We need only follow the evidence and accept where it leads. In some cases, the geometry appears to scale beyond the structure itself. At sites like Teotihuacan and Giza, researchers have observed layout patterns that map ratios of the Earth, such as its equatorial circumference or axial tilt. While controversial, these claims stem from measurement, not mythology. And even if one rejects the planetary encoding theory, the local geometry remains undeniable. Perfect circles, precise angles, mirrored symmetry, across vast scales and heavy materials. These are not the remnants of guesswork. They are the fingerprints of minds that saw the world differently. Geometry, in this context, becomes more than a technical tool. It becomes a language, one that speaks not just of shape and form, but of relationship, proportion, and hidden order. It becomes a silent dialogue between builder and observer, carried across centuries, waiting to be noticed. But what happens when we do notice? What happens when we admit that these patterns are not just impressive, but impossible to explain within the limits of the tools and knowledge we've assigned to these cultures? We're forced to reconsider, not just the structures but the story. That is the power of geometry. It does not argue, it does not persuade. It simply exists, cold and exact, waiting to be seen, and once seen, it cannot be unseen. In the next section, we'll look at what happens when these truths brush up against official narratives and the strange silence that often follows. There's a peculiar phenomenon that arises when incontrovertible evidence contradicts long-held beliefs. Silence. Not the silence of mystery, but the silence of avoidance. The kind that fills the room when someone points to a flaw in the foundation. Too deep, too inconvenient to fix. This is the silence that surrounds many of the world's most anomalous ancient structures. Because once you acknowledge that these stones, these angles, these cuts and patterns do not fit within the known technological capabilities of the cultures credited with them, then the entire story begins to tremble. And so the response is not correction, but omission. Over time, we begin to see how institutional momentum shapes narrative. Textbooks, museum placards, academic papers, they tell a version of history that aligns with established paradigms. It's a coherent progression. Primitive tools lead to basic structures which evolve into complex societies and eventually give rise to modern engineering. It's clean, linear, satisfying. But the stones are not cooperating. Consider what happens when independent researchers or engineers publish findings that challenge this model. Detailed measurements, photographic comparisons, technical analyses of tool marks and load tolerances. The expected reaction, engagement, dialogue, reevaluation, is often absent. Instead, the work is quietly ignored. It doesn't get cited. It doesn't get debated. It simply vanishes from the academic conversation. This is not science, it's narrative preservation. Even more striking are the contradictions within institutions themselves. For instance, you may find a national heritage organization acknowledging that a particular structure is made of granite, cut with precision, dated to 2500 BCE, but in the same breath, insisting it was made with stone hammers and copper chisels. No diagrams, no models, just an assertion. It's as if the acknowledgement of anomaly is allowed, as long as it is never fully questioned. In some cases, the evidence is literally removed. Take the core drill holes found in Egyptian granite. Perfect cylindrical cavities with spiral striations consistent with rotary cutting tools. These features have been documented, photographed, and measured. Yet in recent years, some have been filled, patched, or placed off limits to visitors. Not because of damage, but because of disruption. Disruption to the story. Other anomalies are dismissed with vague terms. Ritual purpose, unknown cultural significance, ceremonial. These phrases are placeholders, not explanations. They deflect curiosity without satisfying it. This deflection is not always malicious. Sometimes it's simply the product of training. Archaeologists are not engineers. They are taught to interpret symbols, not tolerances. So when faced with a borehole that would challenge a CNC machine, they look for cultural meaning instead of technical explanation. But the problem isn't only disciplinary, it's systemic. Funding for digs, access to sites, publication in journals, all depend on adherence to accepted frameworks. Challenging those frameworks is not just controversial, it's career-threatening. And so a kind of intellectual inertia sets in. Not a conspiracy, but a collective hesitance. A quiet agreement to look away. And yet, outside these institutions, the conversation grows louder. Independent researchers, engineers, stoneworkers, machinists, people who know what it takes to shape hard materials with accuracy. They see these anomalies not as mysteries but as data points. They connect dots not with imagination, but with measurement. Some call this alternative history. But that label itself is revealing. It assumes that the current narrative is the default, the baseline, the truth, and that any challenge is an outlier. But what if the current narrative is not the truth, but a consensus? What if it survives not because it fits the evidence, but because it fits the structure of authority? In science, consensus should never outweigh observation. A single, repeatable anomaly should have the power to reshape theory. Yet in historical disciplines, the opposite often occurs. Data is adjusted to fit the model, rather than the model being adjusted to fit the data. This is not a call for conspiracy. It is a call for courage. To look at the stones and admit what they are. Problems. Beautiful, massive, persistent problems. Problems that whisper of a chapter in human history we no longer possess. A chapter of knowledge, mathematical, technical, architectural, that was lost, buried, or hidden. Not because of aliens, not because of fantasy, but because time is a destroyer, and we have forgotten how much we've lost. And in that forgetting, we have silenced the stones. But they are still here, still precise, still impossible, still waiting. In the final closing section, we will take one last step into the emotional and intellectual consequences of facing this truth. Because the story is not only about ancient stones, it is about us. Imagine for a moment that the timeline is wrong. Not wildly, not catastrophically, but just enough to shift everything we think we know about ourselves. Just enough to reframe human history not as a straight line, but as a cycle, a rise, a fall, a memory half buried in stone. Because that's what these megaliths truly are. Not just relics of construction, but echoes of something older, something more complex, something lost. And we don't like to lose. We prefer stories with order, beginnings and endings, primitive to advanced. But the evidence doesn't care about our stories. The stones do not lie to preserve our comfort. They speak a language we've stopped listening to, a language of silence, weight, and precision. What does it mean if these stones were shaped with tools we no longer have? If the geometry they encode comes from minds we no longer understand? If our ancestors were not climbing toward civilization but recovering from something forgotten? That question is dangerous. It doesn't lead to answers. It leads to more questions, to a deeper kind of doubt. The kind that doesn't just challenge history books, but our sense of who we are. And maybe that's the point. Maybe these structures weren't just built to last. Maybe they were built to remind, to whisper to future generations that something greater once stood here. Not as fantasy, not as myth, but as memory. A memory etched in stone. So now the question is not, how did they do it? It's, why don't we want to know? Because the moment we begin to ask, not with fantasy, but with reason, with evidence, with humility, we begin to see the edges of another story, one that doesn't ask for belief, only curiosity. And perhaps that is the most forbidden thing of all, not the mystery itself, but the act of questioning what we're told is beyond question. If this story has unsettled you, good. Let it sit with you tonight as you lay in bed, staring at your ceiling, wondering how many other things, solid, silent, and real, have been explained away not because they were false, but because they were inconvenient. The past is not dead. It's just waiting for us to stop pretending.